Okay, this one's a little bit different. You're going to use synthetic division this time. You're still going to express your result in the polynomial form. Okay. Remember, when you guys are synthetically dividing, if we're doing f of x divided by d of x, when you are synthetically dividing, you are taking your divisor, so this right here, if you set it at equal to 0, so x plus 5 equals 0, so x equals a negative 5, this is what you are synthetically dividing by. So real quick, for example, if we were dividing by, let's say, a 2x minus a 3, that's what we wanted to divide by. We set that equal to 0, and then x is going to equal a positive 3/2, and that is the number that we would divide by. So, I mean, obviously that's not in this particular example, but, you know, just wanted to throw that out there. Oh, I thought this is not my smartboard. This is not make a circle with your eraser and things disappear. That's, dang it. All right, so for synthetic division, just like in polynomial long division, you have to have placeholders. Good grief. Come on there. There we go. Okay. So remember, whatever you are dividing by, it goes in its own little rectangle out here, so it's a negative 5. And you take the coefficients of your polynomial. So we have a 4x to the 4th. You have a positive 19 x to the 3rd. You do not have an x squared term, so guess what goes there? 0. You have an x, so it's a 19, and then your constant is minus 23. That looks like a z, but minus 23. Okay, every time you do synthetic division, whatever number happens to be first comes straight down. This happens to be a 4 this time. Please remember that when you are doing this synthetic division, you multiply diagonally. So you take the negative 5 times the 4, you get a negative 20. And then vertically down your columns, you are going to add. So 19 plus a negative 20 is a negative 1. Okay, you repeat the process. That's all it is. It's just a bunch of repetitive processes over again, over and over again. So negative 5 times the negative 1 gives me a positive 5. Right? And when I add down my column, I'm going to get a 5. Then when technically I should have done that one in red. That's going to drive me nuts. There we go. Boop. Fixed. So then when you repeat your process again, negative 5 times a positive 5 equals a negative 25. So that's heading there. And straight down your column, 19 plus a negative 25 is a negative 6. Okay. And then diagonally again, you are multiplying the negative 5 times the negative 6 is a positive 30. So a positive 30 goes right there. And then adding down the column, you get a positive 7. Sorry, I was going to say a negative 7, but it's a positive 7. Now, couple of things. Oops, wrong buttons again. All right, so we are dividing by this x plus 5. We don't know that x plus 5 is actually a factor of the polynomial. So you guys are probably thinking, oh, but Miss P, we didn't get a 0 here. It's okay that we didn't get a 0 here because we are just dividing these polynomials and we're just doing this with synthetic division rather than long division. Okay. You only get an actual numerical value of 0 at the end if you know for a fact that the number that you are dividing by is a 0 or a root or an x-intercept, whatever you want to call it, of the polynomial in question. Other things to remember. When you have this top line was 4x to the 4th. We have done one round of division, which means this is going to be 4x to the 3rd minus 1x squared plus, because there's no sign there, 5x minus a 6, and then this part right here is your remainder. So when you write this in terms of, in polynomial form, remember it was, sorry, shrinking as I'm talking, it was polynomial equals our answer times technically our quotient times our divisor plus our remainder. So our polynomial was 4, I'm going to try to fit it all in one line, 4x to the fourth plus 19x cubed plus 19x minus 23 equals. All right, the answer that we got was 4x to the third minus 1x squared plus 5x minus 6. We were dividing by x plus 5, and then we have a remainder of 7. So that's what your answer has to look like in polynomial form.